Hello everyone. So in our previous video, we saw the demonstration of the merge sort algorithm via an animation step by step. So in this video, we will actually code the algorithm and will test its working in the main method. So before we start, in case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. So here if you see, I have created one class as merge sort which is having print array method, which we have already discussed that it is used to print the elements of an array on the console. So here we will be creating the method as sort, and as we discussed in our previous video that this sort method will take the original array, one temporary array which will basically help us in sorting the original array. We will take the range from low to high. So usually at the start, low is 0 and high is actually pointing to the last index of the array because we want to sort the complete array. Now in this method, we provide a condition as low should be less than high. Now this is basically a base case because this sort method is actually recursive in nature. We will see later. So in this algorithm, we are actually dividing the array into two parts, the left part and the right part, and we will keep on dividing them till the left and the right part contains only single element because they can't be divided further. And when low will be equal to high, it means we are having only single element. So we need to return from this method because we can't divide the array further down. So when low is less than high, now we will divide the array into two parts. So for that we need to figure out the mid index. So here we evaluate mid. So we use the formula low plus high minus low divided by 2. So here you can see these are nothing but indexes. We can use this formula which will evaluate as the mid index. So this formula also takes care of the integer overflow condition. Let's say our array is huge, which we have already discussed in our previous video. If the array is very small and it fits into the integer size, we can also use this formula low plus high divided by 2. Because here you can see why we are using this formula is because these are two integer values, and if we are doing addition of it, let's say if low and high are at any particular value of integer, when we do sum of it, it crosses the integer limit. So therefore we will get some garbage value. So therefore on the safe side we do this. We do minus of both the ranges so that the overall value is still in the integer range. So after evaluating the mid, now as this is a recursive algorithm, we'll call sort again. So we break it down the array into two parts, and the range would be, for the left it will be low to mid, and for the right it will be from mid plus 1 to high. So here you can see this is a recursive algorithm and it keeps on dividing till there are only single elements left which can't be broken further down. So after getting to that point, as single elements we treat them that they are already sorted because there is only one element. From there on we try to merge them together, and this merging keeps on going till the final array is sorted. So in the merge method, we pass the array, we pass the temporary array, we pass low, mid and high. Why we are passing all the three values is because in the merge, based on low to mid, that will be our left sorted sub array. From mid plus 1 to high, will be our right subarray which is sorted, and we are simply merging two sorted arrays to get a bigger sorted array. So we'll code the merge method now. So here you can see we have this original array and we have this temporary array. We know the range that it goes from low to high. Low to mid is our left subarray. Mid plus 1 to high is our right subarray. So before merging the two sorted arrays, we can't directly merge them in the original array. So in order to merge the two sorted arrays, we take the help of this temporary array. What we do is, we provide a for loop which starts from low and goes till high index. So what we are doing is, now we are simply copying the elements of the original array into the temporary array. So this is what we discussed in our previous video in greater detail. So here we do temp of I, array of I. Now we have got our range from low to high in our temporary array, and we also know that from low to mid we have the left subarray which is sorted. From mid plus 1 to high we have a right subarray which is sorted, and now we need to merge these two sorted arrays such that the resultant array is also sorted. So in one of our previous videos we saw that how we can merge two sorted arrays. So we will apply the same algorithm here. So for more understanding you can watch that video. So here we will create now three variables, I, j and k. So here I will traverse left sorted subarray, j will traverse right sorted subarray, and k will merge both arrays into original array, which is this. So if I is traversing the left sorted subarray, we know that it should start from the low, because from low to mid we have the left part, and j should start from mid plus 1, because we know that the right sorted subarray is from mid plus 1 to high, and we also know that as we are merging the two sorted arrays within a range from low to high, k should also start from low and it will go till high. So after creating these 3 pointers, we will now compare each and every element of the left and the right subarray, and whichever element is small, we try to fit in that element into the original array at kth index. So this is the basic idea behind merging two sorted arrays such that the resultant array is also sorted. So we have provided while loop, and the condition we provide is I should go till mid and j should go till high, and if any of this condition breaks, the while loop will terminate. So here what this condition suggests is, when we are merging the two sorted arrays, there will be a point where either left array will get exhausted or the right array gets exhausted. So whichever gets exhausted, this condition will break respectively and we will come out of the while loop. So inside this while loop, now we'll try to compare the left array's ith index value with right array's jth index value. And as these two arrays are already sorted, that's why we are doing the comparison with the respective indexes. So we do if temp of I is less than equal to temp of j. So here it means whichever value is present at the ith index, it means the left sub-array value is small. So at the original array, at kth index, we will put temp of I, and after placing the temp of I, we know that left array's one element is at its correct position, so we'll increment I. And else we do the other way around, array of k, temp of j, and we'll increment j by one position, because we have taken up one element from the right sub-array. And here you can see we are actually filling the original array at kth index. So after this if else block, as kth index is filled up, so we also increment k by one position to fill in up the next element. So this while loop will again go on like this till any of the array is exhausted. So here you can see that now there are two cases which can arise. Either the left array gets exhausted or the right array gets exhausted. So here when the left array gets exhausted, all the elements of the right sub-array we don't copy it back to the original array, because those elements are already at their correct position in the original array. Because when we are copying the elements from the original array to temporary array, and as both the arrays are sorted, so the elements of the right sub-array which are left over will usually be at their correct position in the original array. So these two cases we discussed in greater detail in our previous video. Now we only need to keep in mind is if the right array gets exhausted first, then we need to write some logic to put in the left array's leftover elements into the original array. So for that we provide a while loop, and the condition is exactly the same, because this I is pointing to an index from where the leftover elements are starting, and we can simply copy it back to the original array. So what we do is we can simply copy it something like this, temp of I k plus plus and I plus plus. So it is a simple loop which is copying the elements at ith index of temporary array into the original array at kth index, and after copying it we are incrementing both the pointers. So once this method will end, the smaller left and right sub-array will be sorted, and then as it's a recursive algorithm working like this, so it keeps on merging the left and the right sub-array till the point all the elements are sorted in ascending order. So now let's test its working in the main method. So here we have created this array 95243. Here we will call the sort method. We'll pass the array which is our original array, and we need to pass a temporary array, so which is of length same as our original array. So we'll do new int array.length. We pass the low as 0 and high as array.length -1, because at the start low is at the 0th index and high is at the last index, which is array.length -1. And after doing the sort, we will print the array and we'll see whether these 5 elements are actually sorted or not. If I run the main method, so here you can see it's sorted as 2, 3, 4, 5, 9. Now let's suppose if I put one value here as -1. If I call it again, so here you can see it's sorted in ascending order. So friend, this is all about the merge sort algorithm. So friends, I hope you must have liked this video. In case if you are new to my channel, then please subscribe to my channel and click the bell icon so that you never miss any update. Thanks, have a nice day.